For generations, Pluto was little more than a ghost at the edge of our solar system, a pale dot adrift in eternal twilight. A frozen exile so far from the sun that daylight there is little brighter than Earth's moonlight. We imagined it as a dead world, forgotten, unreachable. Then, in 2015, NASA's New Horizons spacecraft streaked past it, and in an instant, everything changed. The images arrived and the world stopped. There it was, a living landscape of glaciers and mountains, its heart-shaped plain gleaming under the dim sun. For the first time, Pluto was no longer an idea. It was a place. But buried in the data was a mystery no one expected, something so strange that NASA's team, for all their triumph, couldn't explain it. Pluto was too cold. Not a little, dramatically so. The models said its atmosphere should hover around -173 degrees Celsius, but the instruments said otherwise. It was 30 degrees colder. In space science, that kind of discrepancy is enormous. Not a rounding error, not sensor noise, a cosmic anomaly. Something, somehow, was draining heat from Pluto's skies faster than physics could allow. For nearly a decade, that question hung in silence, a quiet puzzle orbiting the sun with Pluto itself, unsolved, unexplained, and almost forgotten. Until now. Because the James Webb Space Telescope, humanity's sharpest eye in the cosmos, has finally turned its gaze toward that frozen world. And what it found has shaken even the most cautious scientists. When New Horizons first swept past Pluto, researchers expected to find an icy relic, scarred and ancient. Instead, they discovered towering mountains of solid water ice, their peaks higher than the Rockies, and sprawling plains of frozen nitrogen smooth as glass. But above that alien surface floated something impossible, a veil of blue haze, delicate as silk, glowing softly against the darkness. That haze wrapped Pluto like a dream, thin but breathtaking, stretching almost 300 kilometers into space, far higher than anyone thought possible for such a small planet. It shimmered in sunlight, stacked in layers like faint, ethereal clouds. And yet, beneath its beauty hid the true enigma. It was too cold. No combination of nitrogen, methane, or carbon monoxide could explain the numbers. Scientists rebuilt their models from scratch, checked every instrument, every line of code, every calibration curve. But the math refused to cooperate. The energy didn't balance. Something invisible was stealing heat, siphoning it away into the dark. Then, in 2017, a planetary scientist named Zhang from the University of California, Santa Cruz, offered a theory that sounded less like physics and more like poetry or madness. What if Pluto's haze wasn't just passive dust drifting through thin air? What if it was doing something, chemically alive in a sense, actively regulating the planet's temperature? According to Zhang, those tiny particles suspended high above Pluto could be absorbing ultraviolet light from the distant sun and re-emitting it not as visible light, but as mid-infrared radiation, a form of heat. Except instead of warming Pluto, that process was doing the opposite. It was bleeding energy away, radiating warmth out into space far more efficiently than gas molecules ever could. In essence, Pluto's haze was acting as a planetary heat shield, cooling it like a mirror that glows in the dark.
At first, most scientists laughed it off. The idea that microscopic haze particles could dominate a planet's thermal balance flew in the face of everything planetary physics taught. But Zhang made a daring prediction, one that could be tested. If his hypothesis was right, Pluto's haze would emit a very specific mid-infrared glow, faint but distinct. A signal so subtle that only one instrument in existence could possibly detect it, the James Webb Space Telescope's Mid-Infrared Instrument, or MIRI. And in May 2023, the test came. An international team led by Tanguy Bertrand pointed Webb toward Pluto and its moon, Charon. Webb's clarity was unmatched, For the first time in human history, it could separate the faint heat signatures of two worlds orbiting side by side over 5 billion kilometers away. Using MIRI, they scanned Pluto across multiple infrared wavelengths, 15, 18, 21, and 25 microns, and when the data came back, jaws dropped. The readings showed a radiant signature far stronger than expected, glowing from high above Pluto's frozen surface. Something in the atmosphere itself, something unseen until now, was radiating heat in the space. It wasn't just a reflection of sunlight. It wasn't from the ground. It was something else. And in that faint, ghostly glow, shimmering across Webb's detectors, lay the answer to a 10-year mystery, and perhaps a glimpse at a kind of planetary process we've never witnessed before. When the team finally stripped away Charon's light and isolated Pluto's own spectral signature, the truth hit like a thunderclap. There it was. The pattern Zhang had predicted 6 years earlier, etched across the data with mathematical precision. The haze wasn't merely scattering sunlight, it was glowing. Pluto's atmosphere was radiating heat, not from the surface, not from trapped gases, but from the haze itself. A faint, mid-infrared exhale whispering energy back into space. The missing heat NASA couldn't account for? They'd just found it. The haze wasn't a side effect of Pluto's cold. It was the cause. That single realization rewrote decades of planetary science. Everything researchers thought they knew about climate, energy balance, even the fundamentals of atmospheric chemistry had just been overturned. For generations, gases were thought to be the masters of climate. Carbon dioxide warming Venus, methane shaping Titan, water vapor driving Earth's weather. But Pluto told a different story. Here, tiny solid particles, microscopic, tar-like molecules called tholins, were in control. These strange compounds form when ultraviolet sunlight strikes methane, kicking off a cascade of chemical reactions that build complex hydrocarbons, molecule by molecule. Over time, these tholins drift downward, layering Pluto's atmosphere into shimmering sheets of haze. And as they float, they glow in infrared, bleeding heat into space and cooling the planet from above. It's as if the entire world functions like a vast chemical engine, pulsing in rhythm with its orbit. Haze forming, glowing, and collapsing in an endless atmospheric heartbeat. And then came a twist almost poetic in its beauty. Webb's sensors picked up methane leaking from Pluto, streaming outward and gently settling onto Charon, its icy moon. There, under faint sunlight, that methane transforms into reddish organic compounds, the very material that paints Charon's polar regions in rust-colored hues. In the simplest, most literal sense, Pluto is painting its moon.
But even that wasn't the biggest revelation. Because hidden deeper in Webb's data was a suggestion that chilled and thrilled the scientific community alike. Pluto might not be alone. The same haze-driven cooling Zhang described could be happening elsewhere, across our solar system, maybe even across the galaxy. The first place scientists looked was Titan, Saturn's giant moon, already known for its thick orange smog and methane-rich skies. When Webb turned its eye toward Titan's horizon, the results sent shivers through mission control. The same infrared wavelengths that defined Pluto's strange glow appeared again, only stronger. Titan, too, seemed to be radiating its energy in mid-infrared light, as though its atmosphere were breathing, exhaling heat into the void. The resemblance was uncanny. Researchers began calling Titan and Pluto mirror worlds, two distant orbs of ice and haze, each following the same hidden chemistry. Then, from even farther out, Neptune's moon Triton joined the conversation. Webb detected faint heat signatures there too, a thin atmospheric whisper hinting that its nitrogen haze might be performing the same cosmic trick. Suddenly, a pattern emerged. These weren't silent, frozen outposts. They were active worlds, speaking to one another across billions of kilometers, obeying an invisible rule book,
a code of light and chemistry that seemed to govern the edge of the sun's reach. And when scientists examined the haze particles themselves, the story deepened. Webb's spectroscopy revealed that these tholins were far more complex than anyone had imagined. Molecular jungles of hydrocarbons laced with nitrogen and oxygen bonds, the very elements that form amino acids, the building blocks of life. On Earth, similar reactions take place high in the atmosphere when sunlight strikes methane, the same photochemistry that may have helped spark life billions of years ago. So suddenly, Pluto's haze wasn't just cooling its atmosphere, it was cooking chemistry. Dr. Tanguy Bertrand put it best: this is prebiotic photochemistry on a planetary scale. And yet, even as the data painted this breathtaking picture of connection and creation, the mystery only deepened. Because what Webb saw next, what the numbers began to whisper about these faraway worlds, hinted that the same chemistry shaping Pluto's sky might be touching something far more fundamental, something that blurs the line between physics, biology, and perhaps intention itself. Officially, the emission was labeled instrumental interference. Unofficially, the room went quiet. No one spoke for nearly a full minute, not out of disbelief, but out of instinct. They all knew what they'd just seen. The lead data engineer quietly reached over, locked the file, and marked it for internal review. Within hours, the report vanished from the public archive. A few weeks later, Webb's official data release omitted the night-side readings entirely. The justification: thermal contamination, a sterile phrase to bury a miracle. But secrets have a pulse of their own. Whispers began circulating through late-night channels between observatories. Snippets of code, blurred screenshots, fragments of the waveform labeled PL247. Someone at Goddard had leaked a copy, not the raw data, but enough to show that the pulse was real, enough to start a quiet war between belief and protocol. One of the scientists on the original team, Dr. Eleanor Ross, couldn't let it go. She'd spent a decade analyzing infrared signatures from exoplanet atmospheres. Nothing ever repeated like this. She started comparing the 247-second pulse to Webb's deep field archives, looking for resonance patterns. And she found one. Buried in a dataset from January 2025, in observations of the interstellar object 2I Atlas, the same mysterious body Avi Loeb had been studying. There it was again, the same oscillation, the same ratios, the same mathematical fingerprint hiding in the background noise of an object that shouldn't have any structured emission at all. The connection hit her like cold fire. Pluto, the silent outpost of our solar system, and an interstellar visitor, separated by billions of kilometers, speaking in the same numerical language.